Remember the boundary fence at the end of Pure 1 trigonometry? Sec, cosec, cot, compound angles, the R form, all marked off as not yet. Well, the fence is down. This unit hands you the whole grown-up toolkit, 3 new ratios, a stack of identities, and the formulae that finally let you take the trig of a sum. It looks like a forest of formulae, but almost all of it grows from one seed, the addition formula for cosine. Learn to trust that seed and double angles, the R form, and the rest sprouts straight out of it. Fewer things to memorize than the formula book would have you fear. First, 3 ratios that are nothing to be scared of. They are just the old 3 turned upside down. Secant is 1 over cosine, cosecant is 1 over sine, and cotangent is 1 over tan. The only trap is the naming. Sec pairs with cos, cosec pairs with sin. Check the third letter, and you will never mix them up. From these flips come 2 new identities, and you get them almost for free. Take the famous sine squared plus cos squared equals 1, divide every term by cos squared, and out pops 1 plus tan squared equals sec squared. Divide instead by sin squared, and you get 1 plus cot squared equals cosec squared. 2 identities, 1 parent. Here is the big one, and the single most common mistake in all of trig. The sine of a plus b is not sine a plus sine b. It never was. The real formula mixes both angles together, sine a cos b plus cos a sine b. Cosine is similar but sneakier. It flips the sign in the middle. Learn these 2 cold. A work taste, cos of 75 degrees with no calculator. Write 75 as 45 plus 30, feed it into the cosine formula, drop in the exact values you already know, and you land on root 6 minus root 2, all over 4. An ugly angle, an exact answer, that is the whole party trick of addition formulae. Now watch a whole family appear for free. In the addition formulae, just set b equal to a. Sine of a plus is sine 2a, and instantly you get 2 sine a cos a. Do the same to cosine and you get cos squared minus sin squared a. No new memory work, the double angle formulae are the addition formulae looking in a mirror. Cosine's version has a secret talent. Using sine squared plus cos squared equals 1, you can rewrite cos 2 in 2 more disguises, one with only cosines, one with only sines. That last form, cos 2 equals 1 minus 2 sine squared, is the engine that lets you integrate sine squared later. Each disguise is the right tool for a different job. A favorite exam shape, a cosine wave and a sine wave added together, a cos theta plus b sin theta. It looks like 2 waves, but the addition formula run in reverse squashes them into a single shifted cosine, a cos of theta minus alpha. 1 clean wave with 1 amplitude and 1 phase shift. Finding the dials is pure Pythagoras and a quick angle. The amplitude r is the square root of a squared plus b squared. The phase alpha comes from tan alpha equals b over a. So you compress 2 waves into one, read its peak straight off as a, and solving the equation becomes trivial. 2 unknowns, 2 tidy formulae. Last tool in the box, the factor formulae. They do for trig what factorizing does for algebra, turn a sum of 2 sines or cosines into a product. Why bother? Because a product equals 0 is easy to solve, and a sum equals 0 is not. They come straight from adding and subtracting the addition formulae. And that is the secret of the whole unit. You are not memorizing 20 unrelated spells, you are learning one parent formula and watching its children appear. Sum to product, double angle, R form, all of it traces back to the trig of a sum. Know the parents and the family comes to you. Here is the whole unit as one poster. On the left, the reciprocal trio and their 2 identities, sec, cosec, cot, with 1 plus tan squared equals sec squared. On the right, the parent that rules them all, the addition formulae for sine and cosine, with cosine flipping its middle sign. Underneath, the children. Double angles come from setting b equal to a. The R form squashes a cos plus b sin into one shifted wave with r the square root of a squared plus b squared, and factor formulae turn sums into products. Master the parents at the top, and this whole page rebuilds itself. And the boundary fence so you do not over-revise. There is no need for the calculus of these functions here. Differentiating and integrating sec, cosec, and the rest belongs to the calculus units. And there are no triple angle formulae to learn. You build those when asked from double plus single. This page is the whole game.